So in this video, we define the inverse of a matrix using the adjoint matrix that we just developed. So here's the claim. The claim is that if we have a square matrix whose determinant isn't 0, then A has an inverse. In other words, A is for sure invertible. And the inverse can be calculated by taking, the inverse here can be calculated by taking 1 divided by the determinant of the matrix times the adjoint matrix, which we just constructed in the previous couple videos. So this isn't a wonderfully efficient way to calculate a matrix inverse. We've already developed a technique for calculating matrix inverses using Gauss-Jordan elimination and appending the identity matrix to the coefficient matrix and then reducing that into reduced row echelon form. And that's a much more efficient way of calculating a matrix inverse. However, the method that we came up with for calculating matrix inverses using Gauss-Jordan elimination, it doesn't give us a formula for the generic n by n square matrix. And so where this is useful is for theoretical purposes and for trying to develop new theorems and find properties, for example, of matrix inverses. And the reason it's useful is it gives us a pat formula for the inverse of a square matrix A. And clearly you can see why you need to claim that A can't be 0, because right here, if the determinant were 0, we'd have a division by 0, which is undefined. So this is very tedious but straightforward formula to use, and we'll use this formula in the homework, and we'll use it in a subsequent video, but it's not a particularly fun formula to use. But it is theoretically important. The proof of it, which I think this proof was stolen from Gareth Williams, this proof spans 2 slides. And what I'm going to say to you is that you should take the time to read the proof and try to understand it. Part of becoming a budding mathematician is to develop the skill of seeing a claim. Somebody makes a claim, and not just being content with using this. That just being able to use something doesn't get you very far in your mathematical life. So here's a nicely typed up proof of this claim, and it might take you 15 minutes to dissect it and understand it, and you should take the time to do that. The key to understanding this proof is to understand this piece right here. If you can wrap your head around this piece, then it kind of unlocks the rest of the proof and makes it pretty straightforward. So understanding this piece requires that you understand completely the paragraph that comes before it. You know, what happens when I equals j? Oh, it gives you diagonal elements that are just the determinant of A, and any of the non-diagonal elements in the matrix that you get when you take this product gives you a bunch of zeros. So I would write the proof down and take the time to try to understand it, and not just be content with using the inverse formula in the homework. You should take 15 minutes out of your life to really tear into this. Here's the first slide. Here's the second slide. I'd get it into the notes and try to dissect it. Why is the circled piece right here true? If this is true, the proof plays out pretty easily.